The universe is a vast cosmic ocean. Somewhere, something incredible is waiting to be known.
The cosmos is all that is, or ever was, or ever will be. Our contemplations of the cosmos stir us.
Had Carl Sagan not passed away, today, November 9th, would be his 83rd birthday. I imagine a large part of the audience for this channel remembers Sagan, and fondly so, and I am no exception. He is one of the great inspirations for this channel. Sagan was one of the world's best-known futurists. He and I have some things in common in that we are both scientists, futurists, and techno-optimists with a deep belief that our destiny lies up there in the stars. I've always tried to emulate what he did so well by making the topics interesting and straightforward. Not to oversimplify them, but to explain what can be explained in a way that doesn't overcomplicate things. Cosmos, Sagan's famous TV series in the 1980s, came out right after I was born. I can't remember when I first saw it, probably when I was quite young, as my mother was a fan of his. I've probably seen every episode at least a few times. I guess what's always stuck out to me is that the Cosmos series reveled in the mystery of the universe, but also sought to explain it. That always seemed the right way to present material. There are many areas where Sagan's work intersects with my own, and I'm going to spend some time in this episode looking at that in more detail. While Sagan was and still is a major inspiration to me, we do not agree on everything, but that is not particularly surprising or undesirable. There is also a lot more technology and observations that have changed our views of the universe from the time Sagan did his most famous work in the 1980s and 90s. It's hard to overestimate the impact Sagan's had on this channel, and I wanted to point out some of the cases I've drawn on his work today. We all stand on the shoulders of giants, and while Sagan did as well, he was one of those giants, and his work permeates our discussions of these topics and themes. Sagan liked to talk about the stars, but he also liked to speculate about alien civilizations that might dwell around them, and that is a topic we have covered under a slightly different heading on this channel, so let's start there. Sagan believed that extraterrestrial life is possible and probable. I also tend to think simple alien life is probable. Sagan believed that an alien planet with sentient alien species was distinctly possible, and asked in the Cosmos episode titled One Voice in the Cosmic Fugue whether we were alone, or as he put it, is there a cosmic fugue, a billion different voices playing the life music of the galaxy? To address Sagan's question of whether we are alone or not, we need to consider the Fermi Paradox, which at its simplest is an apparent contradiction that despite a high probability for the existence of spacefaring aliens, that there is no evidence that such aliens actually exist. Sagan had far fewer tools and much less data to work with back in his day, and he admitted this in that Cosmos episode where he said, "For the first time, as we will see, we've begun a serious search for the cosmic fugue." That serious search, from what we have gathered so far in the 30+ years since, shows that the Fermi Paradox is real, and we see no evidence for any alien species that have reached Kardashev 2, also known as K2, status, where they are able to make use of all the energy produced by their local star. A K2 civilization would put out very distinct telltale signs in the infrared spectrum that we would have picked up by now. That is important because, as I've discussed in our earlier episodes, we are already nearing the point where our technology will enable us to become a Kardashev 1 level civilization, where we utilize all of the energy available on our planet, and then quickly transition into a K2 civilization. If we put the effort and resources into it, we could probably be a K2 civilization in just a few centuries. Given the relatively short period of time that it would take us to become a K2 civilization, why have we not seen any of the expected telltale signs of aliens that have already achieved that level of development? Sagan referred to a lot of the risks of self-annihilation in his TV series Cosmos. He highlighted these with reference to the use of nuclear weapons and potential ecological disasters. What Sagan was in effect warning about is that self-annihilation is one example of a great filter, which we discussed in our earlier episodes on great filters. I don't happen to agree that self-annihilation is a particularly strong great filter, but given the lack of any evidence of alien K2 civilizations, it certainly cannot be ruled out as a factor. In contrast to Sagan, I happen to believe that the major great filters are set in place earlier in the developmental cycle of life, in the phases between the creation of the conditions that give rise to life, its development into multicellular organisms, and to the development of a sentient brain. In the end, though, we arrive at the conclusion that the Fermi Paradox is probably explainable using great filters. Sagan was very much in favor of space colonization, believing humanity is driven by a guiding force of our genetic heritage that makes us humans unique and that binds us together. He believed that that force of exploration and the desire to escape a potentially devastating future on Earth should drive us to colonize the solar system and beyond. I too believe that we are destined to colonize space and the stars. We recently explored the colonization of Mars in an episode of our Outward Bound series. Sagan explored this too in his Cosmos episode titled Blues for a Red Planet, where he set out how such a mission could be accomplished, much of it prophetic. He suggested the use of robotic missions, which, of course, we have already done with the Mars rover's Spirit, Opportunity, and Curiosity. He also saw an interplanetary ship constructed in Earth orbit that would carry humans to Mars too. I happen to believe that the materials for such a mission would be best sourced from the Moon, meaning that such a mission would be more conveniently assembled in lunar orbit, but Sagan's vision for the future of Mars exploration is now much closer to becoming a reality by the likes of SpaceX. While he discussed almost every area of science, his first love was always his own field of astronomy. And while this channel spends a lot of its time in space, we do not spend too much of that on astronomy itself. Yet the universe is an immense place of infinite wonders, and I thought for today we'd spend some time on those. Voyager 1 is a space probe that is in the process of leaving our solar system. In 1990, at the request of Sagan years earlier, a photograph of Earth was taken by Voyager 1 that shows Earth 3.7 billion miles away to be nothing more than a pale blue dot, which became the title of one of Sagan's books in 1994. If this channel could be said to have any single main focus, I suppose that it would be ways of venturing out from our pale blue dot of a homeworld and exploring and colonizing that vast cosmic ocean all around us. One of the things we do on this channel is try to take the science we know and the technologies which we either have now or look like safe bets and try to guess at what the future will actually look like. To get out there to the stars, we tend to assume we would need some way to travel faster than the speed of light, but we have no solutions for that at this time, and prospects look grim. Popular science likes to discuss warp drives and wormholes, and we've explained them here in the FTL series, but the sad reality is that they do not appear to have very realistic options for ever being developed. If they do, that's great. I won't hold my breath though. However, I'm not willing to give up on space travel just because of that, and, as it turns out, we don't have to. Our focus today, and on the channel in general, isn't to say various fantastic technologies won't ever be invented, but to challenge the assumption that we must have them to succeed at seemingly overwhelming challenges, such as colonizing space. I'll quell my skepticism on FTL drives as soon as someone hands me a bottle of water containing a negative liter of water, a yardstick that is -1 meter long, or a real number that when multiplied by itself has a negative value. Fundamentally, every proposed FTL method seems to rely on things like that, mathematically valid concepts that do not appear to have real physical analogs. Though truth be told, I'd be very worried about any prototype engine that folks thought was going to pull it off. As we've discussed before, FTL only exacerbates all the problems we have with the Fermi Paradox, and if it turned out to be possible, I would start wondering if we might have some serious flaws in our perception of the universe and life. Sagan, like most physicists, also took the view that the speed of light could not be exceeded, so I'm in good company here. So we will not break the speed of light in this episode, but we will break our preconceptions of what space is. The classic image we are given from sci-fi, and indeed even science, is that the galaxy is an immense, barren void. To think of solar systems in this light, one can picture a vast desert thousands of kilometers across, in which a handful of oases no bigger than a small pond exist, and these are solar systems. Of these, only a tiny percentage would have yellow stars like our own, around which a few might have an Earth-like planet or one close enough that we could terraform it. And this image is accurate enough, indeed still a bit generous. Were we to imagine a light year was 100 kilometers, these oases, these solar systems, would tend to be many hundreds of kilometers apart, and their habitable zones would be just a meter or so across. One of those grains of sand would be a planet, and scaled up properly, such a desert would need to be 10 million kilometers across. This is the classic view. However, it ignores that we might cultivate that entire little pool rather than a single grain of sand in it. This is what we mean when we speak of Dyson spheres, but that's not the end of it, because while the space between the oasis star systems is huge, it isn't entirely empty. Most of the material in the galaxy is not inside stars, not even including dark matter, which is most of it. That regular matter is mostly floating around in the interstellar void, and much of it accumulates into small bodies. A good deal more of it is simply hydrogen gas, waiting for its chance to end up in a star one day. However, to cover that vast gulf between stars, we almost have to have fusion, the very process that turns that hydrogen into energy in the sun. We've discussed some possible workarounds should fusion turn out to be impossible after all, but for my part I think it is something we will crack this century. Indeed, we technically cracked it in the middle of the last century. But if you want to use fusion bombs as a power source for electricity or spaceship drives, you have to build to quite a large scale. In the Cosmos episode Journeys in Space and Time, Sagan discussed a fusion-powered craft called Project Daedalus that travels at 10% of light speed. I always think it is important to remind people of that, since many are skeptical of fusion and like to repeat that bit about it being the technology of 20 years from now and always will be. We aren't trying to invent fusion reactors, we're trying to invent compact ones that can just power a city rather than a planet, or propel a spaceship smaller than New York City. We've talked about ways to do space travel if we never get compact fusion working. Sagan discusses the Project Orion plans in Cosmos that would make use of hydrogen bomb explosions to propel an interstellar craft. More modern ideas like the interstellar laser highway offer higher speeds than a fusion or fission drive could obtain. But the key point is that if we assume we do have fusion plants, we also have the ability to make interstellar spaceships. No other technology is required, even if there are several that would make it much easier. However, loosely speaking, it takes something like 10 to the 20th power joules of energy to move a person to another neighboring solar system in less than a human lifetime. In terms of energy, that's also enough to support someone for millions of years, even if you have to make artificial sunlight to grow their food. So the same reactor that makes traveling to other stars with habitable planets possible makes it less necessary to find those rare planets like Earth to call new homes. Every icy rock meandering about the outskirts of our solar system suddenly becomes every bit as attractive as a new home as a near-Earth clone. Terraforming planets is in many ways just as hard or harder than constructing an equal amount of artificial habitats. Sagan also explores the possibility of colonizing the Oort cloud in his book Pale Blue Dot, and we will be looking at that concept in December. This isn't going to stop folks from building interstellar ships and heading off to stars, but it means rather than civilizations occupying just a few astronomical units near a star, each separated by hundreds of thousands of AU from their neighbors, you'd likely find habitats spread throughout that whole volume, each a little cactus in the desert. At a basic level, the cost of interstellar travel isn't about distance so much as speed, and the energy needed to get there and back. That's another problem with traveling very fast. The closer to light speed you get, the more energy it costs you, and it rises very steeply. Something most people discussing hypothetical FTL methods tend to gloss over is that not only do these systems all rely on the square root of -1 having a real physical expression, but they are massive energy hogs even compared to relativistic spaceships. As I just mentioned, relativistic ships tend to need energy supplies in the output range we tend to associate with powering national economies. So the three basic objections to going to the stars slowly tend to be that you die before you got there, that you never skip off to another solar system to shake hands with aliens, and that you can't fly around inspecting spatial anomalies. The first of these was dealt with by Sagan, who suggested the use of generational ships in the Journeys in Space and Time episode. It's also entirely possible that we will figure out how to extend people's lifetimes or freeze them and thaw them out, what Sagan calls hibernation. People always seem weirdly skeptical of this, but not of FTL travel. Tell people you are going to build a swarm of star-encompassing megastructures or extend the human lifespan, and they don't believe it, even though both are demonstrably inside the laws of known science. Tell them we can never build the Millennium Falcon and go zipping around the stars, and they think you are being defeatist and short-sighted. I also mentioned two other things, that you can't go meet aliens, and that you can't go investigate space anomalies. Given enough time, you will always be able to meet aliens, since even ignoring deliberate technological intervention in terms of genetic engineering, you will have a lot of drift. Humans colonizing a galaxy and taking a few million years to do it are going to be about as human or like each other as you are to a cat or dog. Remember, they're family too. They're just like your millionth cousin 10 million times removed. You don't even have to be in another solar system. After all, your cat and dog aren't. The sheer immensity of things like Dyson swarms and Kardashev 2 civilizations allows a lot of divergence. And when we throw in accelerated mutation from genetic engineering, options like cybernetics or uplifting, and the large number of pathways transhumanism or artificial intelligence might take, you could easily have thousands of alien civilizations living inside your home solar system that were 10 times as alien as the critters we usually see in sci-fi. They wouldn't even necessarily share any DNA with you, or even use DNA, and you can go around discovering them all you like. You wouldn't be the first, they'd have whole volumes discussing their culture logged in the Encyclopedia Galactica, but they're new to you. Alternatively, if there are alien civilizations out there, that's probably going to be the case for them too. I mean, we've barely been in space, not for long nor traveled far, and we already shipped off naked pictures of ourselves and a roadmap to our house. And odds are good at least one or two other civilizations would be older but equally open to contact. Though admittedly, if someone moved into my neighborhood and acted that way, I'd probably start ducking their phone calls and having my evenings filled with fictitious affairs that made me unable to attend a housewarming party. That leaves us our third one, which is exploring space anomalies. Unfortunately, while the universe is a fascinating place full of many things which are beautiful and strange, this isn't Star Trek, where you wander into bizarre new space anomalies every week exhibiting new physics. To make matters worse, that's not how rational civilizations explore weird anomalies either. You shoot unmanned probes to look at such things first. You do this because science is interested in understanding, not excitement, and we will not launch huge manned expeditions that could imperil lives for no realistic gain simply because people want excitement. It's unethical and irresponsible, even more so than having all your senior officers beamed down to investigate the matter. Makes for good fiction, but not good science or responsible management. If we spot an anomaly, we'll eyeball it from afar, launch a probe to do a flyby. Ships that don't have to slow down can always go faster than ones that do, then follow that up with one that does slow down but can still get there faster than a manned ship. Then, at last, if it still isn't solved, a manned ship might go there, likely after hundreds if not thousands of probes have flitted by or parked to monitor it. Even that manned ship is really only necessary if you don't have FTL, so that you can get intelligent critters on the scene rather than dealing with all the time lag for communication. You cannot send a very smart unmanned probe because that's essentially an oxymoron. If your probe is smart enough to be doing the sorts of thinking we'd otherwise prefer to send a team of experts out to do, you probably shouldn't be viewing it as expendable or unmanned. So it's really only in a no FTL universe where you'd be likely to ever have direct contact with anomalies or undiscovered civilizations, since you can't remotely control your probes and drones from light years away. And while there are anomalies in space, and one should not think of space as almost entirely empty, or made of bits that are like all the other bits, Space Explorer is unlikely to ever be a common job title, at least in terms of wandering around on a spaceship, just visiting systems and looking at them. I suppose you could anyway, but I can't imagine any nation or group authorizing a huge ship to be built to run that way. Would you trust a multi-century expedition to be run by someone who thought poking next to an anomaly for a close look by the crew was a good idea, rather than one who tends to launch a lot of probes there as advanced scouts? Just because exploration wouldn't be the primary purpose of a given ship, that doesn't mean it wouldn't get any done. Colony ships will certainly do lots of exploring when they arrive, and will have before they got there too. You could have an interstellar ship that was quite small, indeed potentially smaller than a person, since the crew need not be biological. Or it could be quite big, yet still have a small crew simply from excellent automation. Self-repairing systems might be quite elaborate, and steering through deep space isn't too complicated. Indeed, we tend to expect that, after all, whether you are using AIs to run a ship, or actually making a living ship whose intelligence regards the ship as its body, a big space whale if you would, we would expect to use a ton of automation on ships. Yet I would tend to expect them to be quite large and with large crews, and the reasoning is twofold. First, as with colonizing deep space rather than just solar systems, the same technology that lets you automate a ship to need only a small crew also lets you automate the factories that build those ships. Any decent-sized asteroid of the kind we have thousands of in our solar system contains quite enough material to fashion thousands of giant fleets, one for each system we'd be likely to settle directly. If you can build ships that can maintain themselves, then you can build factories that can make those ships by themselves too. So fundamentally, the same technology that lets you build a self-maintaining vessel lets you crank out giant armadas on the cheap too. And I don't think finding volunteers for colonization will ever be too hard. Either you need that many people to maintain the ships, the ecology to be transplanted, and the civilization to be transplanted, or you don't but can easily include them. The thing is, you need all that size and all that crew because you aren't exploring, nor are you sending off a seed. If we want to plant our civilizations in alien soil under an alien sun, we have to plant our civilization, not just a few people. You took centuries to get there, and the civilization you left is now probably dust, no more the home you knew than a foreign country would be. Even messages from home are old. Settle 20 light years away, and a communication back home would be received by someone who had to go look up the original message written by his predecessor talking about this cool new movie called Star Wars. Running a ship or a fleet for centuries of travel might be something that can be done automatically. Perhaps even transplanting an entire ecology might be done so. But a whole civilization? I don't know about that. Now, theoretically, an artificial intelligence might fly to some planet in a ship no bigger than a football, unpack and start building the infrastructure to grow and clone a whole ecology from digital DNA records, including people it might raise from birth in the traditions of their civilization. Thing is, again, if you've got a machine that smart, I'm not sure you'd want to rely on it to do your colonizing for you, since it raises a host of not just technical problems, but ethical ones as well. You're sending out splinters of your civilization that would diverge a lot from the original. They might begin that way, some specific cultural, ideological, or religious group funding a colony. But even if you send out one that started with a random and fully representative cross-section of all culture, it would mutate in time, and a very short time as these things go. We'll talk about that more next month when we get to interstellar empires and giant colonial fleets shortly after that, when we close the year out with an episode on intergalactic colonization. We'll also discuss some of those problems, ethical and technical, with using AI later this month, but this is not an episode on those topics. However, they speak to our ability and motives to get out there and explore the cosmic ocean. For my part, I don't think we need any other motivation but to explore and to go out there, but it's nice to have them, and I do not think we need apparently impossible techs like FTL to do it. If we get them, that's great, but if not, It won't stop us. And it's a point that I always feel is important to stress these days in this role I've stumbled into as a science communicator, especially when folks often feel frustrated by how slow we seem to be extending our reach, nearly half a century after the first and last manned moon landings. We can do it, and we have plenty of time to turn that dream into a reality. A century is not even an eye blink in the lifetime of the universe. But it can be a bit depressing to have to wait on that because a century might be an eye blink to the universe, but it is all the time we tend to be given. In that respect, I think it's important to remind ourselves of the challenges we face and how much effort it takes to solve them, and that we continue to make that effort and make progress. That's why I think folks like Carl Sagan did such a service to humanity by outlining these visions. I wouldn't say that Sagan was the first science communicator. Even for television, that title probably better belongs to Don Herbert, better known as Mr. Wizard, but Sagan had a unique way of speaking about science that could fill audiences with interest in the mysteries of the universe. And while he was hardly blind to the faults of humanity, he always advanced a viewpoint that was fundamentally optimistic and inspirational. His impact on many aspiring scientists, myself included, can never be underestimated, and his ability to convey all the wonders of the universe to his audience inspired millions and opened up the doors of the imagination for them. For that, he has my deepest gratitude, and I'm honored to dedicate this episode to him. Until next time, thanks for watching, and have a great week.
Countless worlds, numberless moments, an immensity of space and time.